Okay, awesome. So guys, like I said, I don't want to waste your time. I just need 10 minutes of the time maximum, to be honest. I'll start in a minute. Just waiting for my notes now to. Okay, let's do it like this then. Anyways, yeah. If I do this, can you guys still see the screen if I do that?
Yes,
Okay.
sir. We can see the screen.
Yes, Roger is visible.
Okay. Just loading. Load it. Okay, well, thank you guys for joining. My name is Gabriel Nembenge, and this is the grade 12 class. And the duration of this lesson is gonna be 10 minutes or 15. So the topic here today is I'm gonna be discussing with you guys about the transfer of thermal energy, where we're gonna talk about conduction, convection, and radiation. So this these are objectives. So by the end of this lesson, I expect you guys to clearly be able to clearly explain heat transfer through a material without material movement, provide example, distinguish from other heat transfer mechanisms, emphasize real world applications of materials with different thermal conductivity, as well as to be able to define radiation as heat transfer through electromagnetic waves. So, as you know, you guys probably have heard already of the term thermal exchange of thermal energy. You guys maybe want to tell me what thermal energy is? What do you guys know about that? What about the transfer of thermal energy? Okay, so literally, the transfer of thermal energy is just the transfer of energy from one point to another, and transfer of heat from one point to another. And these are things that happen on our everyday life. Like you wonder how things are done. We cook, and energy is being transferred every single time. I mean, it's hot currently, and then it gets cold. So this topic is quite relevant in our everyday life. So moving forward, um, conduction, we can define conduction as, hold on, I don't know how to put this thing. Okay. Sorry guys, just bear with me. Okay, so we can define conduction as a flow of heat through a material without any flow of the material itself. What do I mean by this? Is you have, say, a metal from one end to another, and then you hit the other end of the metal, and then you receive, or you'll be surprised to learn that there'll also be heat on the other side of the metal. So that's how conduction happens. So how it actually happens is there's a transfer of electrons happening through that metal that transfers now the heat energy from one point to another. And the aim of this transfer is to reach a state called thermal equilibrium, where every part of the metal will have the same temperature. So an example to that, again, you can like just try to heat up the copper wire from one side, and or just an iron from one side, and then you experience heat on the other side. Okay, moving forward, we have now properties of a good conductor of now heat. So The characteristics of a material with high thermal conductivity, example, copper, aluminum, and so forth. So what this actually means is there are metals that have a higher level of conductivity than other metals because they can transfer, they have more free electrons to transfer this heat energy. Okay, so and then we have now, what about the properties of poor conductors? So other materials, they don't really have free electrons within themselves to transfer now these free energy from one point to another, and we call them non-conductors in most cases, and wood is one of them, and we have rubber and so forth. And then we move on to our second mode of heat transfer, which is convection. Convection by definition is just a flow. Usually it happens in liquids or gas caused by a change in density in which the entire medium moves, carrying heat energy. So for example here, what happens is when you boil water or you boil coffee at home, the heat is going to start from the bottom of the pot. And once you boil that, or once you heat that bottom, that water will actually now get heated up, and its density will sort of reduce, and then it will rise, and then the water above, which is now colder, it will move down, and circulation continue until what? Until we reach the thermal equilibrium. Okay, now we have discussed so far conduction and convection. Just a quick recap, just so you don't confuse them. Know that usually conduction happens in metals, and convection appears usually in gases and liquid. So another example of convection is temperature. When it gets cold, it means that now the air has risen, it's up, and so forth. So it's gonna continue like circulating like that until we reach our thermal equilibrium. So we move on to our third mode of thermal exchange, which is radiation. So radiation is a transfer of heat by electromagnetic waves, not requiring a medium. This has to be underlined, not requiring a medium for heat to be transferred. So what do I mean by this? So look, think about the sun, for instance. The sun every day pours out unending rays, and there is no medium then. There is no water in which that heat is transferred, or there is no direct contact or metal from the sun to the earth for energy to be transferred, but then they use what we call electromagnetic waves. So what are these electromagnetic waves? So these are just waves that transfer energy in a vacuum. So what happened there in the sun is, once nuclear fusion happens in the sun and the heat is, and then the hydrogen is transferred into helium and so forth, the energy is now transferred to us in terms of UV lights and infrared lights, as well as light via electromagnetic waves. So without running out of time, we have come to the conclusion of our presentation. What we have literally discussed here, these few minutes that we have spoken here, is we have spoken about how heat is transferred from one point to another, which is the concept of thermal energy transfer. So anybody maybe who just want to like explain to us what we have spoken? Any questions so far? No questions? Okay, fine. If there's no questions, Farhan?
No questions. That was clear.
Yeah. Okay. So yeah, moving on to the conclusion, guys. It's very important to understand the different thermal energy transfer mechanisms, and why is it important is because it happens every day in our everyday life. We experience this. For example, it's hot now, and you switch on the fan, the circulation of that air, it's giving the, you know, the transfer of energy or heat energy rather in different mediums here. Talking of conduction, convection, and radiation and how energy is transferred. So without further ado, I'm wasting your time, unless you guys have questions for me. And if you guys don't have questions for me, then I leave you guys with the homework. And I need you guys to bring this homework by Monday. So, and yeah, the notes, I will upload them on the LMS for easy accessibility and also in the WhatsApp group. So the homework is just, I just expect you guys to define thermal energy and explain its importance in our daily life, identify and describe 3 main types of thermal energy transfer, conduction, convection, and radiation, and I need you guys to explain them briefly. And it's an individual work, okay? Again, thank you guys for bearing with me. I know you guys have other important things to do, but you found time to attend to my class. And thank you very much, unless you guys have any questions for me.
I have no questions, sir.
Okay,
No question is clear.
until then, guys, until next time, thank you very much and have a lovely night.
Yes, thank you very much.
Thank you, sir.
Yes, bye.